Hello, welcome to the exida OEMx video. In this video, we'll explain how to save time doing an FMEDA analysis by gathering and organizing the information needed for the FMEDA using ARCHx. ARCHx is one of the tools in the OEMx suite, and although it's commonly used for design, failure mode, effect, and analysis, it also can be used to gather up the FMEDA information, which is what we'll talk about today. A failure mode's effects and diagnostic analysis is done to predict a set of reliability metrics that are used for many reasons. And perhaps number one, design improvement, field reliability performance predictions, functional safety verification, and in many cases, customer assurance. A good FMEDA needs to consider all the environmental stress factors, design strength features, mitigations, your automatic diagnostics, your preventions, and any latent fault or proof test procedures. That list gives us an idea of what we need to look at. But first I want to ask, with all that value, doesn't everybody do an FMEDA on every project? And the answer is no. And there are many reasons, but number one reason given to me by engineering managers is that the FMEDA takes many hours. It's not just worth the cost, especially given our workload. I understand. Early on, I had an engineer explain, I just finished the FMEDA on an embedded controller board. It took only 2 months. He was very proud of that. And I thought, 2 months? That is a lot of engineering hours. We need to find ways to get things done faster and at a higher quality level. I understand because that engineer was using the way we started FMEDAs when we created the concept back in the late 80s. Back then, we knew we needed a hardware schematic or an assembly drawing. We knew we needed a bill of material. And we know we needed parts specifications. And given that, we could dive right into the design because we know what we're doing. And the analyst traces through the circuits back and forth, going from the inputs to the outputs and thinking about each component failure mode and how it would impact the outputs and the operation. That's pretty time consuming. And often you get to a component where you say, C30 fails with a high leakage, the 5-volt drops. That's what I'm worried about. What's the device level impact of this? Is there a mechanism to detect this failure, or is it hidden, latent? Let's call the designer. You go to the designer, and he's busy. The designer calls you back a week later and says, which capacitor? And you pull out the schematics because you're now working on another FMEDA, for example. And after about a half-hour discussion, you get the answer to your question, and then you have to think, well, how did that circuit work? And you start tracing through it all over again. I can understand. In fact, we clearly understood why it took so long to get an FMEDA done. And as we gained experience, we realized there's a lot of things we could do to help speed up the FMEDA and improve the quality. And the number one reason is gathering up the information up front before starting the FMEDA. Now, we know we needed the schematics, the bill of materials, and the component specifications, but what else? It's really important to look at the architecture design blocks and the functions of each block because we want to know what the failure modes of each block are. Now, that's normally an essential part of an FMEA. What are the mitigations? If you have a function, a failure mode of a function block that is not acceptable, then you have to do something about it, a mitigation. Commonly, they're prevention or detection. Detection mechanisms are commonly automatic diagnostics. And for every automatic diagnostic, how effective is that diagnostic on this particular unit failure mode? And perhaps more importantly, what do you do when you detect a failure? I mean, do you have some mechanism to tell the world? There's an enunciation mechanism to tell the world the failure occurred, or do you feel you have to take the outputs of your device to a fail-safe state? You must decide, and the FMEDA needs to know that decision. Any design strength features, board coding, we need to know all that so we can give you credit for good designs. Is there any offline latent test that can be done to detect specific failure modes? And what are the chances this latent fault test will detect the mode? We'd really like to know all that. And of course, just remind you, we do have a white paper describing action taken in detail for those who want to dig in deeper. We developed, one of our engineers, John C. Grebe, developed the concept of the functional FMEDA. And in that method, we've learned we can really improve quality and reduce engineering time. For every block in the architecture design, we enter a unit type. And for that unit type, we get the block failure modes and the mitigations. If a mitigation is automatic diagnostic or latent fault test, we assign the diagnostic coverage. We assign the effectiveness of that mitigation. And we classify each block failure mode according to the device level, failure, safe, dangerous, enunciation, and so forth. That's all done in ARCHx. It's a lot of the work that's part of an FMEDA, but it's all done in the ARCHx tool. Once we have all that information, for each block, we enter the components. For each component failure mode, all we have to do then is map the component failure mode to the block failure mode. And we go through and do that for each component. Now, it's still work, and you still have to think a little bit. But you don't have to think nearly as much because you're not tracing through a circuit. You know this block has this failure mode, and this component results in that block failure mode. Drastically simplifies the mental effort, and once you do that, the job is done. It's pretty cool. For example, we start with this architecture, and here's an example where we have 4 function blocks: power conditioning, voltage regulators, and a over-voltage, under-voltage monitor. And we can see, we document the intended functions of each block. How do we use the ARCHx tool to gather up and organize all this information? Well, for each functional block in the architecture, we load a unit type. In this case, for example, I picked the 5-volt voltage regulator, and I picked a unit type, buck switching voltage regulator. And the knowledge base gives us a list of known failure modes and a list of proven mitigations. We check the ones we want, uncheck the ones we don't want, and load. When we load, that unit goes into the tree structure, which documents the architecture. And you can see right away the automatic diagnostics that we have selected are now there. And they came from the knowledge base, which saves a lot of time. You got to think about it, make sure you're checking the right things, but the knowledge base saves you a lot of time. For each failure mode, each deviation, for example, noisy output on the 5-volt power supply, we'd like to know what is the potential device impact. Now, the default is already here, but you can select the one you want from the pull-down list. And now we have documented the block and potential device impact. For any automatic diagnostic, like we've just picked the low voltage monitor and over voltage monitor, and we said, well, for this particular failure mode, noisy, how good is that? Well, it depends. It depends on where the thresholds are set and how noisy the power supply is. The database gave it a 90% effectiveness, and it does assume you've set your limits correctly. And we've designed in an analog circuit. Our diagnostic test interval is basically 50 milliseconds. We can modify that diagnostic, but we know now the diagnostic coverage for this particular failure modes, and it's all provided for you in the knowledge base. Pretty good. What action is taken? We can specify that from the mitigation node editor. For this particular mitigation, we have chosen to enunciate the failure via a dedicated output. Now we know exactly what will happen. What about the latent fault tests? On the deviation node editor, we can specify a particular latent fault test and estimate the diagnostic coverage. Everything is organized and in place. We know the architecture design blocks. We know the automatic diagnostics and how effective they are. We know what action is taken. We have any design strength features as protective mitigations. We know if there is all the offline latent fault tests specified, and we know how good they are. We are ready to do our FMEDA. Bring in the OEMx tool and run a quick demo for you. The first thing I'm going to do is look at the power conditioning block. So I'm going to create a unit for that. We get the load unit knowledge screen. What kind of unit is this? This is my PC circuit. I know I want a hardware unit knowledge. Let's see, what is it? Power conditioning block. Okay, the potential failure modes are, that's quite fascinating. Connector faults. Well, I'm going to use connector keying, so we don't have a problem there. Do I have overcurrent limiting? Yes, I do. I want that put in. Do I have input voltage clamping? Yeah, we do have that. I checked that on my spec. Loss of power supply input. Yes, there is an undervoltage monitor there. There is no overvoltage on that. We have limiting. All right, let's just think. All right, I think we're in good shape. Let's load this in, and now we've documented the power conditioning block. I'm going to go ahead and add the 5-volt regulator. The load unit knowledge screen comes up. This is my PS VR5. What kind of a block is it? It's hardware. It's a buck switching voltage regulator, and my knowledge base has provided a good set of failure modes. We call them deviations here in light blue. I think those are all valid. Now, do I have yes, I checked my specs. I definitely have a low voltage monitor on the 5 volts. I have a low voltage and an over voltage. I have an over voltage monitor, and I'm going to load. You can see my architecture now appears on the tree, and I have a very good definition of what's going on. Now, let's just check this power supply. If there's a connector fault, what's the impact? Dangerous. Yep, I'm going to accept that. I don't know that I have a latent fault test for that right now. How about the connector keying? Well, that is a prevention, and it's very high effectiveness. For every one of the deviations, I can enter the impact. Output voltage goes to 0. Good. For this one, I do need a diagnostic. This is a diagnostic, so I'll give it 50 milliseconds. All right, we're in pretty good shape here, and you can see we have gathered up all the information we needed just as fast as that. Take a lot of time if you're not using a good tool to help you gather the information. If you are interested in learning more about speeding up and improving the quality of your FMEDAs, don't hesitate to ask us for more information. If you'd like a demo version of OEMx, don't hesitate to ask and we can help you get started. I thank you very much for your attention. Let us know what you think in comments. Never hesitate to let us know. Take care. Bye-bye.